Now let's have the important discussion on the difference between power transformer and distribution transformer. From this you will know what power transformer is for and what distribution transformer is for. Power transformers are used in transmission network, whereas distribution transformer is used in distribution network, and power transformers rating generally will be greater than 1 MVA and distribution transformers rating will be less than 1 MVA, and voltage ratings will be greater than 33 kV, and whereas in case of distribution transformers voltage ratings will be less than 33 kV. And the other point is here that power transformer is indirectly connected to load, whereas distribution transformer is directly connected to load, which means load fluctuations effects are more in case of distribution transformer, whereas in case of power transformer load fluctuations effect is less. And the fourth point is it is 24 hours loaded, whereas loading on distribution transformer depends on load cycle. This is the important point from which we will derive few more points. As the power transformer is 24 hours loaded, so copper losses and iron losses present for all 24 hours, whereas here iron losses present for 24 hours but copper losses depends on load cycle, because copper losses depends on the load current. And in case of power transformer, as the power transformer is loaded for all 24 hours, means there are copper losses and iron losses present for the whole 24 hours, whereas distribution transformer is loaded according to the load cycle. So when there is load connected, then there will be copper losses, but for all 24 hours the primary of distribution transformer is excited, means iron losses present for all 24 hours but copper losses present only when load is connected. So in designing transformer, importance is only given to reduce the iron losses and importance is not given to copper loss, because copper loss is present or not present, that depends on the load cycle. So in designing, importance is given to reduce iron losses. Therefore low magnetic flux density material, amorphous silicon steel is used for core. And coming to power transformer, as the power transformer is continuously loaded for all the 24 hours, so the iron losses and copper losses are also present for all the 24 hours. Therefore here in designing, importance is given to reduce copper losses. And here for core the material used is CRGO steel, and CRGO steel will have good flux density. And the other important point is, as the power transformer is 24 hours loaded, means the average load is full load because it is continuously loaded for all the 24 hours. So here X is equal to 1, that is maximum efficiency occurs at X is equal to 1. And coming to distribution transformer, here loading depends on the load cycle and the max efficiency will occur at around 3/4 load, and we have a relation that X is equal to root over iron losses by WCU full load losses, and if you place X is equal to 1, which implies WCU full load is equal to WI. This is the condition. And whereas in case of distribution transformer, WCU full load will be approximately equal to 2 times WI. Performance of power transformer depends on power. Therefore the efficiency here is power efficiency, whereas in case of distribution transformer, performance depends on power and time. Therefore, efficiency is all-day efficiency.